Hello, welcome. In this short video, let us look at an example illustrating the superposition principle and the Coulomb's law. Consider a charge Q which is located on the center of a circle of radius R and which is surrounded by 12 charges which are located on the vertices of a regular 12-sided polygon. Note that these charges are also on the circle at equal angular distance of 30 degrees from each other. That is, we have Q here and then next charge is located. So we have 12 charges located on this circle at equal angular distances of 30 degrees. So this is 1, this is 2, this is 3, this is 4, charge 5, 6, 7, 8, 9, 10, 11 and 12. This can be a good way to imagine this type of setup is that the charges are located on the numerals of a wall clock. So now the goal is to find the total charge, total force on the charge Q at the center of the circle. Charge Q at the center. By superposition principle, the charge on the center of the circle is the sum of the charges from I equal to 1 to 12 of Fi. That is, where Fi is the charge due to the ith charge on the charge at the center. That is, F1 is equal to 1 by 4 pi epsilon naught into Q1 into capital Q by R square into R1 hat, where R1 hat is the unit vector from the direction of Q1 to capital Q. Clearly, for this setup, the each unit vector R1 has exactly an opposite unit vector which will cancel it. That is, for this Q1 we have Q7 as the charge at the 7th location as the exactly opposite unit vector. That is, F1 bar plus F7 bar is equal to 1 by 4 pi epsilon naught into Q by R square into R1 hat minus 1 by, and of course there is Q. Since Q1 is equal to Q2, Q1 is equal to Q2 is equal to Q3 up to Q12, that is all the charges are equal, then we have Q here, and the next F7 is 1 by 4 pi epsilon naught minus of 1 by 4 pi epsilon naught into Q into small q by R square into R1 hat. That is, R7 hat is equal to minus R1 hat. So this is it. And then the sum is obviously equal to 0. Similarly, F2 bar, that is the force due to charge Q, will cancel with force due to 8th charge, and F3 will cancel the force due to charge 3 will cancel with the force due to charge 9 and so on. And finally, force due to 6th charge will cancel with the force due to 12th charge. And the final force, that is 1 by 4 pi epsilon naught, that is the total force, is equal to, using the formula, that is I equal to 1 to 12 Fi bar, we have summation 1 by 4 pi epsilon naught into small q into capital Q by R square, summation I equal to 1 to 6 Ri hat plus summation I equal to 7 to 12 Ri hat. But the unit vectors from 7 to 12, that is unit vector Ri hat from 7 to 12, is exactly, each unit vector is exactly equal to one of the corresponding vectors in this set. That is, set from 1 to 6. That is, we have 1 by 4 pi epsilon naught into Q into capital Q by R square, summation I equal to 1 to 6 Ri hat is exactly in this summation of the vectors can be replaced as minus of I equal to 1 to 6 Ri hat. So this is equal to 0. Therefore, the net force on the charge Q is 0. And for in a special case where one of the charges is removed, then the net charge on the charge Q will be equal to the charge due to the opposite is equal to the force due to the charge at the opposite location. That is, for example, when Q1 is removed, then the net force on Q will be equal to the force due to the charge at the 7th location. And then when Q2 is removed, the net force is the force due to the charge at 8th location, and so on. Thanks for watching.